The ozonolysis is a series of pericyclic and retropericyclic reactions. The oxygen negative charge will attack the more substituted side of the alkene. That builds up too much electron density around this carbon. The pi bond will break. The less substituted side will use those electrons to attack the oxygen involved in the double bond. That builds up too much electron density around that oxygen, so we'll break the double bond, giving those electrons back to the positively charged oxygen. We'll take one of the lone pairs on the oxygen. It actually doesn't matter which of the two oxygens you use. And we'll drop those electrons down to form a new carbon-oxygen pi bond. That builds up too much electron density around that carbon, so we break the carbon-carbon sigma bond and use those electrons to form the second carbon-oxygen pi bond. That builds up too much electron density around oxygen, so we break the weak oxygen-oxygen bond and deposit those electrons as a lone pair on the central oxygen. That allows us to take the lone pair on the negative oxygen and attack the carbon of the carbon-oxygen pi bond. That builds up too much electron density around carbon-3, so we'll break the CO pi bond. Oxygen will get to use those electrons to attack carbon-2. That builds up too much electron density around carbon-2, so we'll break the other CO pi bond and give those electrons back to the positively charged oxygen. That forms our second 5-membered ring intermediate. Whether it's sulfur or phosphorus, we'll use the lone pair on the heteroatom to attack one of the oxygens in the oxygen-oxygen single bond, not the lone oxygen between two carbons. The oxygen-oxygen bond is very weak, and when attacked, the oxygen-oxygen bond will break, swinging the electrons over to form one of our carbon-oxygen pi bond. That builds up too much electron density around carbon-3, so we break the carbon-oxygen bond and swing those electrons over to form the other carbon-oxygen pi bond. The carbon-2 oxygen bond breaks, oxygen gets to keep those electrons to form a pi bond with sulfur. The product of the ozonolysis reaction is two unique carbonyls.